Projectile motion. This is when an object is thrown and creates a path like this. By the way, this is always a parabola. What are the forces involved? We have velocity and of course the force of gravity. Projectile motion is easiest to understand and solve when you realize that this is composed of two independent parts, horizontal motion and vertical motion. We just have to create two sets of equations for each. And take note, to simplify, we neglect the effects of air resistance. So let's have here our first example for projectile motion. We are being asked to solve for h. Now, an object is thrown at 20 meters per second and the distance of the wall is 50 meters. The object will end up in this wall, so let's find h. First, we will create an equation for horizontal motion. Vx is the x component of the initial velocity, so that's 20 cosine 40. This is the Vix, the initial velocity in x direction. Sx, which is the distance traveled, so that's 50 meters. The formula for the distance traveled is Vi times t. There is no acceleration. From this, we will substitute 50 meters is equals to 20 cosine 40 times t. We will get the time. So that's 50 over 20 cosine 40, and t is equals to 3.2635 seconds. Then let us proceed to the vertical motion. The initial velocity in y is equals to 20 sine 40. So sy is equals to negative h. Negative h because the motion is going downwards from the starting position. We have a negative y, and of course we have positive y. Sy is equals to, by the way, there is an acceleration on the y, which is negative 9.8 meters per second squared, positive if the gravity is upward, but the gravity is downward, so negative. So that's 20 sine 40 times time. The time in the horizontal is the same as the vertical, so we get this 3.2635 seconds plus 1/2 of the acceleration, which is negative 9.8 times 3.2635 squared. So we can calculate, so that's negative 10.29 meters. That is negative h, so the h is 10.29 meters. So that's the answer. Now to recap, we solved the horizontal motion, we get the time, and the vertical motion, we use the same time in the horizontal motion. So there you have it. Let us have another example. I have here an object initially at 90 meters per second, then it is thrown and it landed on the same level. We are being asked on how far did the object travel. First, let's have the vertical motion. The initial velocity of an object vertically is 90 sine 30 degrees. This is equals to 45 meters per second. The acceleration, of course, is negative 9.8 meters per second. That is the gravity. So as you can see, the SY is, we have here a Y component, positive Y. From here, the motion is upward and it returned to the 0 level. So that's 0 meters on the SY. From the equation, S is equals to VIT plus 1/2 AT squared. So that's 0 is equals to VI is equals to 45 times T plus 1/2 of negative 9.8 times T squared. This is a quadratic equation, so we can solve this using the quadratic equation solver in the calculator. Now, the coefficient of T squared is 1/2, so that's 0.5 times negative 9.8, and the coefficient of T is 45, and we have a 0 constant. We can solve this. We will have T is equals to 9.1174 seconds. This is a quadratic equation, so we will also have 0, or T is equals to 0. That is because in this equation, the question is when is the object at 0 meters? Of course, from the start and in the end. From the start, the time is 0, and in the end, that is what we're looking for, so that's 9.174. Now we know that the time for this path is 9.174 seconds. We are looking for the range, R. That is actually XX, and the initial velocity in the Y, that is 90 cosine 30 degrees. This is 45 square root of 3, so let's just use 90 cosine 30 degrees. We have R is equals to VIT, so that's S is equals to VIT plus 1/2 AT squared. There's no AX is equals to 0, so this is the equation. Now, S is R, so R is equals to 90 cosine 30 times time, 9.174. Now we can calculate the R, which is 715.04. So roughly that's about 715 meters. Okay, so this is the answer. That's it. Kung sino ka man subong, thank you for listening to our lecture. More power to you, and God bless.